Alrighty, Tommey Reed here. Ended up doing some projects. Basically, I got this tractor mower for nothing. Actually, I did some mechanic work for a friend of mine, and he gave me this. It's actually a complete mower. It's just I'm going through everything. The steering was completely messed up. Look at that. That's pretty bad. So what I end up doing is I'll be making the gear. I buy... Usually it's easier just getting a couple of washers. You can always weld them or tack weld them together to make the gear and then go from there. But I want to show you the update on this hydraulic combustion turbine engine. If you're familiar with a Hero engine, usually a Hero engine has, the old style used to have steam in it. And this is basically just showing the concept of pumping fluid upward into the orifice jets and then causes it to rotate itself. It's using very low power. There's no pressure, just a little volume I'm using, but it gives you a pretty good idea. And this is the more updated one. This is actually it's a $1,000 rotary union, very high pressure, very high speed. And this is basically made by pipe fittings. And I find this is a lot easier than trying to machine a lot of parts. And then I got my shaft that I ended up putting in. But what makes this so unique is that it's going to sit in this, is that I actually have, if you're familiar with the Hero engine, then you're also familiar with the Pelton wheel. And that uses the blades, but what this is a two-stage turbine. So we're using the Hero thrust to actually rotate this, and then we're actually going to be fitting a Pelton outside diameter wheel in there to capture all the wasted thrust, as you can see on there. So I have to still do the Pelton wheel. So basically, when this is going forward, this is going to go in opposite direction. Now, it eventually will cancel out this, because this is going to be moving a lot faster. But the key is, once you put this under load, I'm capturing that thrust that's still trying to turn a generator. So this is going to have a two-stage generator. It's going to have one on the main shaft, which is here. And then it's also going to have one on the outer circumference Pelton design. Basically, I'm going to divert this almost like a diffuser, but instead of diffusing the fluid, it's causing it also to rotate in the opposite direction. So it gives that more efficiency on both sides. So I'm using the thrust. That thrust is doing mechanical work, but it's also kicking outward. So if I capture that, then I can also capture in the opposite direction. And that's basically what that's going to end up doing. That's going to fit in this system here. This is my, basically I put all this together, a little tank where I can have my reserve. And basically we're pumping high pressure fluid into these orifices. This is a roughly, I think it's it should be a 0.1 diameter on each thrust. So I have 4 of them. And when you're dealing with up to 1,000 psi, that's a lot of thrust you're actually connecting. And not only that, I want to capture that load. Once it slows down due to mechanical load, that thrust is still doing work. It's just it's being thrown out and wasted. That's when this kicks in. So basically, what's going to happen is that once this gets going, this is going to use most of that thrust to do mechanical work or generate electricity. And basically it's no different than this. This is a little bit more advanced design, because there's actually what they call a Warts pump inside. So it's a Sparrow that's actually pumping water up too. So I'm still experimenting on this possibility. And this was all done with 3D printing. So it works pretty good for what it is. Other than that, this is an update on the hydraulic combustion engine. This is a prototype number 2. Prototype number 1, the company took it and it wasn't finished to try to steal some technology in the system itself, but I prevented that by filing a provisional patent immediately. So that put a stop to that. So basically, I'm showing the technology that is possible using hydraulics, because that's basically what we're using, hydraulics. But there's also a lot of other important things into this too, because there is some potential extra energy due to centrifugal forces. Not much, but it does add to the input of power. So how I'm actually going to drive this is through the hydraulic combustion, basically a liquid piston engine. It's going to pump up the fluid inside the chamber. Could be filled with propane or even other biofuels. And then when it detonates, it presses down, almost like a water rocket. But it's a cycle, so it has to go in and out. I have a test bed over here. And this was the testing I was doing on the combustion chamber, using a stepper motor so I can step it. But the problem is that trying to get everything under control, even with a stepper motor, sometimes these valves never work properly, or they had a little leak and threw off the fluid itself. But it does work. So I know the technology is existing, and this is a little heavy, but basically the fluid gets pumped up. This is going to stand vertical. When the fluid is pumped up, once the air and fuel mixture is mixed, it pumps it up, feeds it, compresses it. Now, this can go as high as 800 psi compression, which is unheard of. So it's higher than even diesel it can be, but usually around 150 I like to test it with. And then when it detonates, all that compressed gas from the oxygen and the propane heats up, causes the high pressure to expand. Instead of trying to come out of the exhaust, it pushes it back down, almost like a water rocket. And that's basically what it comes down to. So I hope you enjoyed this little update. Got a lot of work to do. It's a nice day up here. Short Beach, Florida, which is way too hot. I'm sick of Florida. So I'm up in Northwest PA, and I hope you enjoyed this little update. Talk to you later.